Hello, this is Subaru. Welcome to lecture on problem solving techniques on integral solutions of linear equations with unit coefficients and with non-unit coefficients. Let us apply essence of previous session on combinatorial to get integral solutions of linear equations. In a nutshell, the essence of the last class is on following points. If you capsulate all the points what we have done so far in the previous lecture, one is the number of ways in which an identical thing is distributed with blank groups, without blank groups, different things, arrangement, different things, distribution, different things, distributions. So these are the points what we learned in the last session. So now let us apply these points in order to get a more in-depth learning about integral solutions. I'm going to discuss about elementary model questions on integral solutions, limitations to apply, results which we learned in last session, applications using those results. The first question is, find the positive number of solutions of x plus y plus z plus w is equal to 20 under the following conditions. 0 values of xyz are included. Second, 0 values of xyz are excluded. As we finished the theory regarding integral solutions, our interest is in applying previous results. So while you are applying the previous result, make sure variables follow necessary conditions. So 0 values of xyz are included means the first one solution is x is greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0, w greater than or equal to 0, and x plus y plus g plus w is 20. So when you apply previous knowledge, this is nothing but number of non-negative integral solutions of the equation x plus y plus g plus w is 20. So that is nothing but 20 plus number of variables 4 minus 1 c 4 minus 1. So this is 23 c3. So when you come to the second point, zeros are excluded. When zeros are excluded and positive solutions. So when positive solutions, positive integral solutions, this is a positive integral solutions, number of positive integral solutions. X is strictly greater than 0, y strictly greater than 0, g strictly greater than 0, w strictly greater than 0 means x, y, z, w greater than or equal to 1. So in this case, it refers number of positive integral solutions of the equation x plus y plus g plus w is equal to 20. So in such case, so what you can say, 20 minus 1 c, number of variables 4 minus 1, so which is equal to 19 c3. So this question is elementary question on previous integral solutions concept. Now let's go to the second point, second question, in which the variables are not following elementary conditions. How many integral solutions are there to x plus y plus g plus w equal to 29 when x greater than or equal to 1, y greater than or equal to 2, z greater than or equal to 3, and w is greater than or equal to 0. So that means x, y, z are not following conditions which are required for non-negative integral solutions as well as a positive integral solutions. So in order to apply that result, I will make all variables follow same conditions. So for that, let us consider new parameter capital X, which is equal to x minus 1. As the least value of x is 1 when x minus 1 is greater than or equal to 0. Capital Y is equal to y minus 2, which is greater than or equal to 0. Z is g minus 3, which is greater than or equal to 0. And W is already greater than or equal to 0. So in this case, what I can take, capital X plus 1 is equal to x, where capital X is greater than or equal to 0, where capital X is greater than or equal to 0. Whereas in the second case, capital Y plus 2, which is equal to small y, Z plus 3 is equal to small g, which is where capital G is greater than or equal to 0, W is greater than or equal to 0, G greater than or equal to 0. So if you translate this equation into new parameters, then it is translated to capital X plus 1, Y plus 2, G plus 3 plus W is equal to 29. In this equation appears, which is equal to 29 minus 6. So that is 23, in which all parameters are following the condition greater than or equal to 0. That means it is nothing but non-negative integral solutions. So what is non-negative integral solution? Non-negative integral solution 23 plus number of parameters 4 minus 1 C4 minus 1, which is 26 C3. So in this question, most importantly, one must note that x, y, z, w do not obey prerequisite conditions of non-negative integral solutions or positive integral solutions. First, change the parameters which follow prerequisite conditions of those results, and after that you apply it. Coming to third point. In the third question, how many integral solutions are there to the system of equations x1 plus x2 plus x3 plus x4 plus x5 is equal to 20 and x1 plus x2 is equal to 15 when xk, each parameter, is greater than or equal to 0. So therefore, this is system of equations, simultaneous system. So what is the system here? First condition, x1 plus x2 is equal to 15, x1 plus x2 plus x4 plus x5 is equal to 20. So that implies x3 plus x4 plus x5, the sum of three parameters, is equal to 5. So observe, in both the cases, all xi's or xk is greater than or equal to 0. So in both the cases, it is non-negative integral solutions. So for simultaneous equation, the solution of this simultaneous system is nothing but a product of solutions of first equation x1 plus x2 is equal to 15 and second equation x3 plus x4 plus x5 is equal to 5. So answer is 15 plus 2 minus 1 C2 minus 1 non-negative integral solutions into by multiplication theorem 5 plus 3 minus 1 C 3 minus 1 which is equal to 16C1 into 7C2. That's nothing but 1621 jar. That is 336. 336 is the solution. So here, in order to write a solution of system of equations, we apply multiplication theorem. As per multiplication theorem is the product of solution set of first equation and as well as the second equation. So coming to the next model, find the number of non-negative integral solutions of 3x plus y plus z equal to 24 where x, y, z all greater than or equal to 0. So of course the parameters are following prerequisite, that is x greater than or equal to 0, y greater than or equal to 0 and z greater than or equal to 0. But the coefficients of the parameters are not unity. The coefficient of x is 3. So this is the model in which one of the coefficient of the parameter is non-unity. Only one parameter is non-unity. So in such cases what we do, I take x is equal to k. When x is equal to k, we would get x plus z equal to 24 minus 3k. So the first point is write the range of new parameter k. See, y and z can take the zeros. So if y 0, z 0, 3k is equal to 24. So k can be 8. Okay. So what are the limitations of k? 0 less than or equal to k is less than or equal to 8. So k is lying in between 0 to 8. So if you consider 24 minus 3k is a constant, that means for instant a k, what is the solution set of y plus z equal to 24 minus k? For k, for a fixed k, the solution is 24 minus 3k plus 2 minus 1 C2 minus 1 since it is a non-negative integral solution. So that is 26 minus 1, 25 minus 3k C1. So as we know n C1 is n, this is 25 minus 3k. So what are the values of k? K takes values from 0 to 8. So therefore number of solutions equal to sigma for different values of k. K is running from 0 to 8, 25 minus 3k. So when you apply summation 25 into sigma 0 to k 0 to 8, that means there are 9 values. 25 into 9 minus 3 times, this is sum of first 8 natural numbers, that is n into 8 plus 1 by 2, which is equal to 225 minus 4 here, 12 lines 108, which is 117. Okay, so this is the question which tells us when a coefficient of one of the coefficient of the parameter is non-unity, how to proceed or how to apply non-negative integral solutions or positive integral solutions concept. So next let us move on to another model. Find the number of non-negative integral solutions of x1 plus x2 plus x3 plus x4 is less than or equal to n. So which is x1 plus x2 plus x3 plus x4 is less than or equal to 1. It's not equal to n. Right. So all xi's are greater than or equal to 0. Non-negative integral solutions. In such case, there is a gap. So once try to understand this mathematical statement, x1 plus x2 plus x3 plus x4 is less than or equal to n. So there is a gap in between the sum x1 to x4 and n. So let us fill up that gap with a new parameter x5. Let us choose x5 such that x1 plus x2 plus x3 plus x4 plus x5 is equal to n. So I have filled up this gap in between these two quantities by x5. So see, observe here, it is less than or equal to, for some values it is equal to n. So that's where x5 can take values from 0. So x5 can be 0. When x5 is equal to 0, both are equal to n. Alright. So then it is nothing but non-negative integral solutions of this equation. So answer is n plus 5 minus 1 c5 minus 1. Observe, it's not a positive integral, so it is non-negative integral solution. So that is nothing but n plus 4 c4. So the next model which is covered for less than or equal to. So less than or equal to. Now let's move on to one more model. So this is the real application. It's not direct application as we did in last 5 questions. Once try to understand how many integers between 1 and 10 lakh have the sum of the digits 18. So this is a 7-digit number. So 1, 2, 3, 4, 5, 6, 7. So this is 7-digit number. So less than the 7-digit number means our highest number is 6-digit number. So any number in between 1 and this number must be of less than 7 digits. So that means what we want highest number will have 6-digit will have 6 digits. 6 digits in it. So the question arises, if it is necessary to find, is it necessary to find 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, 6 digit, right? So 1 digit anyhow, the sum is equal to 18, not possible. That is not possible. 2 digit, is it possible? Yes, 99. So 9 plus 9, 18. So that is one possibility. So whereas in 3 digits, there are many possibilities. 4 digits. So literally when you find one after another, it becomes very lengthy. So let us try to apply this concept of integral solutions in this particular solution, in this particular question. So I'm taking required number is A1, A2, A3, A4, A5, A6, right? So try to understand all of you. This is 0 less than or equal to. There is a big limitation. You cannot apply. So here, this is a 6-digit number in which the sum of the digits A1 to A6 is 18. So when A1 to A6 is 18, so don't try to apply directly formula. Why? Because you cannot write 18 plus 5 C5. Why? Because parameters are not following our prerequisite condition, that is ai is greater than or equal to 0. Of course it is following ai greater than or equal to 0, but there is a big limitation. ai is less than or equal to 9. ai is less than or equal to 9. So this is the most important observation. So that means if you neglect it, what would be happened? So when order to get, suppose A1, A2 till A5, everything is 0. So then A6 is equal to 18. So that means A6 is taking 18. Is it possible? No. So A6 can take up to 9 only. So we are not able to apply the formula directly. So that means instead of applying the result, we need to follow with method. So what's the method? We got it here. So how we derive? So in the two ways we derive the formula. I mean the result of integral solutions, positive integral solutions and not negative integral solutions. So here because of this limitation less than or equal to 9, what I follow, coefficient of x power 18 in 1 plus x square till x power 9 power 6. So what does it mean? So I need sum is 18. So here there are 6 brackets, 6 factors. Each factor is having a possible value of 0 to 9, 0 to 9. So we are dealing with the powers only 0 to 9. So the value which is chosen from the first factor will be allotted to A1. Second factor will be allotted to A2. The sixth factor will be allotted to A6. That means this coefficient of x power 18 in this product is nothing but number of ways of choosing AI such that A1 to sum of A1 to A6 is 18. I hope the point is clear to everyone. So which is equal to coefficient of x power 18, as we know from geometrical progression, this is 1 minus x power 10 power 6 into 1 minus x power minus 6. So as we learned, binomial expansion for negative integral index. So this is coefficient of x power 18 in 1 minus 6c1 x power 10. No need to write the second term onwards because second term would be 6c2 x power 20. But we are looking for only 18, x power 18. So those terms will not have any role in order to find the coefficient. So I neglect in writing next terms. So what about this 1 minus x whole power minus 6? So try to understand here. Coefficient of x power r is r plus 6 power minus 1 c r minus 1. This is the coefficient of x power r in the expansion of 1 minus x whole power minus 6. Right. So in this case, into 1 minus x whole power minus 6. So there are two things. When this term is multiplied by 1, this term, the coefficient of x power 18 is obtained when 1 is multiplied by a term which containing x power 18 in this expansion. So that is nothing but 18 plus 6 minus 1c minus 1 minus 6 into 6c1 into x power 10. In order to get x power 18, multiply this term by x power 8 in the second expansion. So for that 6 plus 8 minus 1 c8, which is equal to 23 c17. So that is nothing but 23 c5 minus 6 times 14 minus 1 13 c8, that is nothing but 5. Okay, yes. So this is the solution for the question. How many integers between 1 and 10 lakh have the sum of the digits is 18? Okay, so the most important observation from this question is limitation of AI cannot take all values. So AI has a limitation on its upper limit. Okay, so next one more application on integral solutions. Find the number of positive integral solutions for xyz such that xyz is equal to 24. So in that case, what we do, how do we apply? Let us see. Xyz is equal to, this is a one simple question, 24. I will write prime factorization of 24, which is 8 3s are 24, 2 power 3 into 3, right? So try to understand here, 2 power 3 into 3. So we have 2 power 3 and 3 which have to be substituted to or distributed to three factors as three factors x, y, z. So that means 2 power 3 distribution. First let us see the distribution of 2 power 3. So for the distribution of 2 power 3, we can convert it into our previous result that we have three identical objects. Three identical objects must be distributed to three variables x, y, z. So now for our better understanding, I will write x, y, z. In x, y, z, x take x1, x1, x take x1, 2's and y x2 and z x3. So that means out of the three 2's, x1 2's are given to x and x2 are given to y, x3 are given to z. So what do you say here? x1 plus x2 plus x3 is equal to 3. So how many integral solutions? How many non-negative integral solutions? So we can give all 2's to z only. So that means here 1, 1, 2 power 3. So non-negative integral solution. Non-negative integral solutions, that is 5c2. 5c2 is nothing but 10. Okay. So that means indirectly what we are applying here, three identical objects are being distributed to three distinct groups x, y, z. So that is 5c2. So 3 power 1. So that means one identical object is being distributed to three groups. So that can be done in three ways. That can be done in three ways. That is only in three ways. Right? So either to x or y or z. So therefore finally in this case the solution is 10 into 3. So 30. So 30. Okay. Suppose instead of positive integral solution, if the question is given that total integral solutions. In case of total integral solutions, x, y, z equal to 24, you observe that positive integral solution is 30. The product of three terms is equal to plus 24. So in each positive case, if two of the parameters is having negative sign and third is the positive, so then product will be positive only. Three or negative, then product is negative. So that means the favorable cases are two among three must be negative in order to get the negative integral solutions. So that means in each case plus minus minus possible. How can you make plus minus minus in different ways? As we know, this can be done in three ways. This can be done in three ways. So out of 30 positive integral solutions, each solution will give us three different ways in order to get integral solutions. So that means for negative integral solutions, right? So that means we can write it as a 3 times of 30. So total 90 solutions. So if it is a positive integral solutions, 30. Total integral solutions, 90. So you can practice the same thing for 1080. So 1080, the same way you can practice it. So next point is find the order triplets of positive integers which satisfy 20 less than or equal to x plus y plus z less than or equal to 20. So there are two limits, lower limit and upper limit. Both limits are imposed. So in third question we learned with the upper limit. So there is no lower limit. But here both limits are given. So that is 20 is less than or equal to x plus y plus z is less than or equal to 50. So that means what we can write here, solutions of, you can understand this question as solutions of x plus y plus z less than or equal to 50 completely minus solutions of x plus y plus z is less than or equal to 19. So we need the solutions from 20. So we will subtract, because we know with one upper limit how to find the positive integral solutions. So that's why I can make this question as solutions of x plus y plus z less than or equal to 50 minus solutions of x plus y plus z less than or equal to 19. So as we learned in this today's session in question number 5, so we will fill up the gap between x plus y plus z and 50 with a new parameter w. So with a new parameter w, so that is x plus y plus z plus w is equal to 50, right? Yet the problem is positive integral solution they are asking, not non-negative integral solution. In this case, w is greater than or equal to 0. But whereas in xyz is greater than or equal to 1, So let us apply. So let us make w greater than or equal to 0 with new parameters greater than or equal to 1 and apply positive integral solutions. So in that case, you would get 551c3. So whereas in the second case you follow the same way, then 20c3 would be the answer. So then finally 51c3 minus 20c3. 51c3 minus 20c3 is the possible answer. I hope you can understand. I was pretty speed here. Quickly I have written these things. So using the previous knowledge, you can directly apply and understand. So these are the certain level of the questions which we can apply in the first go using integral solutions, positive integral solutions as well as non-negative integral solutions. So let us try to learn the few more applications on positive integral solutions and negative integral solutions in general situations in the next video. Thank you.